Hello, I want to talk about RAG applications today. We'll talk about what a RAG application is, we will look at architecture, and then we'll close it with a demo. So let's get started. A RAG application allows you to do Q&A over your own corpus of content. So let's say you are a financial services company and you have hundreds of documents related to your products, contracts, services, policies. Using a RAG application, you can ask questions. It will basically go out, search for the relevant content related to the question, and provide a precise answer. So at a high level, a user asks a question, the RAG application takes the question, which is a query, goes out, finds only the relevant content related to the question, creates a prompt which has the context and the query, passes it to the LLM. The LLM will do reasoning over it and provide a precise answer to your user. So that's what, at a higher conceptual level, what a RAG application is. Let's take a look at architecture. So to build a RAG application, there are two steps involved. The first step is the ingestion step, where you take the your corpus of content and convert it into a vector format. So this is how it would look. You basically identify all your documents using a tool, LangChain or any other tool. You have to basically break it up into chunks. This is needed because the embeddings API have a limited context window. So once it is broken into chunks, use embedding API to convert the chunks into a vector format and ingest it into a vector database. Once you have your vector database ready, the architecture of the RAG application itself would look like this. A user asks a question, that question or query is converted to a embedding. Using that embedding, a similarity search is done against the vector database to retrieve all the chunks, all the content which is relevant to the query. The application would then create a prompt which has the question and all the relevant content related to it, pass it to the LLM. The LLM would reason over it and provide a precise answer. So if the question is about summarizing something, that's the precise answer would be in a summary format. If the question is a next step type of question or what should I do type of question, the answer would be in that format. Now let's take a look at a POC. So the same architecture, we have built a POC and we'll say, we'll take a look at it. Does it even work, or how does it work? Let's take a look at it now. So in the demo you are about to see, I'm using LangChain and I'm using OpenAI embedding, and I'm also using Faiss, which is a index database. You can think of it as a vector database. So what we'll do is we are gonna take a look at two online articles. These are from this year, 2024. So OpenAI has no knowledge about them. Using LangChain, we'll load them and then we'll convert them to chunks. We'll convert those chunks to vectors and then we'll ingest them into Faiss. Then we'll ask a question. We'll see how the question is basically how the application does a search, creates a prompt with the right context and provides a precise answer based on these articles. So let's move over to the demo. Alright, let's get started with the demo. So first what we're gonna do is we're gonna import, okay, let's take a step back. I'm using LangChain. LangChain is a framework which makes it easy to develop LLM applications, and I'm basically importing a lot of classes which I'm going to be using. Alright, the first thing I need to do is just check, whether my connection to OpenAI APIs is working fine. I have provided the right keys, things like that. So here in this code, I am inputting a very simple question, and that will go as a prompt and come back with the right answer. Okay, so that worked, right? Very simple prompt. What does Microsoft do? Who is the CEO? I can just change this to some other company. And this worked fine. So this code works, and using LangChain, it makes a call to OpenAI APIs, and it comes back with the right answer. Now what I've done is I have selected two online articles. One is this one. This is dated January 3rd, and the other one is this one. It's dated January 2nd, 2024. The reason being, the LLM model has no knowledge about these two articles because they are very recent, and the LLM model is not trained yet. It doesn't have any knowledge about these two. So what we'll do is using unstructured URL loader, and that is over here. Using this method, we will load the documents into a format we can use. So let me run this. Okay, it worked fine. And here I'm showing, let me just do this. I should get okay, 2, great. All right, so now that the next step we have to do is we have to convert this raw data into chunks, right? And I'm gonna use this method to convert this content into chunks. So folks, we are here. We had two documents. We used LangChain. Now we are gonna create chunks out of the raw content from the two documents. Wanna run this? Okay, so it worked. Let me see how many chunks were created. 26. Okay, so two online documents, we created 26 chunks. Okay, next step is we have to convert these chunks into vectors. Okay, so let's see. I'm gonna use the OpenAI embedding API, but I'm gonna use it through LangChain, right? And this is the model that will be called. Okay, and what we are gonna do is each chunk will call the embedding model API, which will convert chunk to vector. Okay, and the dimensions of this vector is gonna be 1536. Okay, so here it is, 1536, right? So we'll do that and I'll show it to you. So first let me test this is working. I'm just gonna try to convert a simple sentence before I convert all the chunks. All right, it converted this text into a vector. Let me see what the length of that vector was. 1536, all good. And let's take a look at the first 4 or 5 numbers of that vector. Okay, all good, right? So this is what we did. Folks, this is very easy and this is very fun. So it's with all the frameworks, it is becoming more and more easy to develop AI applications. Next, what we are going to do is we are going to ingest those documents into a vector store using this method. This Faiss is a library from Meta, which enables you to do similarity search. You can think of it as a small lightweight vector database. That's how you can think about it. And then we are going to, once it's ingested right into the vector database, then we can do Q&A over it. So I'm going to do that. This worked fine. Now let's ask it a question. All right, so we are here, we have created this vector index, and now what I'm going to do is I'm going to ask a question, and the LLM application should convert my question to an embedding, do a similarity search, create a prompt which has the question and relevant content, send it to the model. The model will, look at the context and provide me with a precise answer coming from my custom content. Okay, so let's see, what should I ask it? I'm gonna say, all right, who introduced the California AI Accountability Act? That's a good question to ask. All right, great. That's the right answer. Senator Bill Dodd introduced it, right? So that's the right answer. Here it is, Bill Dodd. So let's ask it some more. That sounds about right. January 3rd, 2024. Here you go. Let's ask some more things. All right, that's great. It impacts companies by holding them accountable for the use of AI and promoting safeguards and consumer protections. That's exactly what the bill does, right? That's exactly what it does. So this demo worked pretty good, right? If you look over here, we have the content as vectors here, and the Q&A is working super fine. Okay. So hope you enjoyed the demo. Again, folks, AI is super easy. And I'll be building more videos in the future. So thank you very much.